12, Chase Dixon.
When you throw a baseball or a softball, it always follows a curved path rather than following a straight path. We know this curve usually works in the favor of pitchers, but not so much for batters or fielders.
But why does this happen? Let's explore the physics behind a curveball. The ball curves because of the way it interacts with the air molecules passing across different sides of its surface. The molecules passing across the top get dragged and pile up on the top of the surface, while the molecules that go across the bottom get pulled along, causing them to spread out, meaning fewer molecules below the ball.
This results in more air and therefore a higher pressure on the top of the ball, which pushes the ball downwards.
This phenomenon is called the Magnus effect.
So now that we know about this, what can pitchers do with it? Well, pitchers use the Magnus effect to their advantage by manipulating the spin rate and spin direction. Pitchers choose the direction in which they spin the ball, and this in turn determines the direction of the Magnus force and thus the direction the ball will break. The spin rate tells us how fast the ball is spinning. The higher the spin rate, the more the ball curves. Spin direction refers to the direction of motion of the leading edge of the baseball. This is the defining factor that differentiates a traditional 12-6 curveball, which dips as if it's falling from a table, from a slider or a sweeper, which will move more side to side. A baseball with topspin will be pushed down by the Magnus effect, creating a downward curve. The Magnus effect will cause a baseball with backspin to fall less than it normally would, but it won't actually go upward. Of course, the gravitational interaction means that any ball, no matter how fast it's spinning, will always fall back down to earth. An interesting side note is that in softball, a rise ball can occur due to the underhand throwing motion and the spin, meaning the ball actually does move upward while going through the strike zone.
If you're wondering how the laces factor into how the ball curves, you're not alone. Scientists, including some of us here at NC State, are actively researching this. So stay tuned as we find out more.